Imagine walking away from a winning lottery ticket because you are absolutely convinced you've, like, rigged next week's grand prize.
Right.
That is exactly what Williams Racing did for this 2026 Formula One season. I mean, they sacrificed a highly successful 2025 car, literally shut off development early despite nabbing those massive podiums in Baku and Qatar, and they poured millions into a revolutionary design for the new rule era.
A massive gamble.
Exactly, a massive gamble. And the result, a car that is so fundamentally broken it randomly lifts its wheels into the air at 150 miles per hour. It completely missed preseason testing, and right now it sits 9th in the standings with just 2, frankly, very lucky points.
Yeah, aided heavily by DNFs from the top cars.
Right, so today you are getting an exclusive, under-the-hood look at the catastrophic failure of the Williams FW48. We're doing a deep dive into the bizarre engineering phenomenon plaguing this chassis, the behind-the-scenes factory collapse that caused it, and the wildly diverging human drama playing out in the garage right now ahead of the Miami Grand Prix.
Okay.
Let's unpack this, because to really understand a failure of this magnitude, you have to start with the stark, undeniable physical reality of the machine itself.
Well, the inescapable reality here is that the FW48 is it's shockingly heavy. I mean, the primary crisis we are looking at is a severe excess of mass.
How bad are we talking?
Really bad. The minimum weight limit for these new 2026 cars is 768 kilos. And if you look up and down the pit lane, rivals operating on much smaller budgets, teams like Haas, Alpine, and the new Audi project, they are hitting that target right on the nose.
Ow.
But Williams, they are lugging around an extra 28 to 30 kilos of bulk.
Wait, 30 kilos?
Yeah, around 30 kilos. And in a sport where teams literally spend millions of dollars to shave off a few grams of carbon fiber, carrying that much excess weight is, well, it's basically an immediate disqualification from the midfield battle.
I think we need to put that into perspective for anyone who isn't, doing the live lap time math on their couch on a Sunday. 30 kilos sounds like a lot for a normal person to carry in a backpack, sure. But what does it actually do to a Formula One car when you hurl it into a high-speed corner at 5 Gs?
It creates this massive compounding penalty. On pure physics alone, dragging an extra 30 kilos around a circuit translates to losing roughly 0.9 to over a full second per single lap.
Full second, just from weight.
Exactly. So over a 50-lap race, you are finishing a minute behind the cars you're supposed to be directly racing against. But the raw time loss is just the most obvious symptom. The hidden, far more damaging consequence here is the total loss of ballast.
Ballast, meaning the weights teams add to the car intentionally, right?
Yeah.
Sounds a bit counterintuitive. Like, why would you ever want to add heavy weights to a race car?
It is entirely about weight distribution. So, a well-designed F1 car is actually built significantly under that 768 kilo limit. Let's say a team built a car that naturally weighs 750 kilos.
Boy.
They now have 18 kilos of incredibly dense tungsten ballast to play with. They can bolt those heavy tungsten plates precisely where they want them, usually at the very bottom of the floor, to perfectly optimize the car's center of gravity.
To balance the handling from front to rear.
Exactly. But because Williams built a car that is naturally 30 kilos overweight from the start, they have zero ballast to play with. None. The weight is permanently stuck wherever the heavy structural parts happen to be bolted on.
So the center of gravity is just totally compromised.
Way too high. The balance is locked in, and it amplifies every single handling flaw the car already possesses.
Okay, I have to stop you there because the math on their development timeline just doesn't make any sense to me. We established that they sacrificed a 2025 season. They had an entire extra year, 12 full months of dedicated, uncompromised wind tunnel and factory time.
Yeah, they did.
So how do you miss a weight target by 30 kilos when you had a year-long head start on the rest of the grid?
I mean, that is the ultimate paradox of this whole situation. The failure didn't happen because they lacked time. It happened because their ambition completely shattered their own internal infrastructure.
What do you mean?
Well, team boss James Vowles recently admitted internally that the FW48 is like 3 times more complicated than anything Williams has ever attempted to manufacture. This wasn't just a standard year-over-year evolution. It was a complete revolution of their entire design philosophy.
Right.
And that unprecedented leap in complexity essentially detonated the factory's enterprise resource planning system.
The ERP, let me make sure I'm wrapping my head around this. The enterprise resource planning system, it's basically the digital nervous system of the factory, right?
That's a good way to put it, yeah.
It tells the machines what to build. it tracks the carbon fiber supplies, and it coordinates the thousands of parts moving through the assembly line.
You've got it perfectly. A modern F1 car is made of roughly 80,000 individual components.
Yep.
Yeah. And the software is what keeps that massive orchestra playing in time. Because the engineering team designed thousands of hyper-complex, totally unfamiliar parts for this new 2026 car, the legacy ERP software they were using just couldn't process the load. The digital tracking completely collapsed.
Oh, man.
Suddenly you have a factory producing parts utterly blind.
It sounds a bit like trying to execute a massive home renovation, but the architects, the plumbers, and the electricians all lose their blueprints on the exact same day.
Yeah.
So everyone just starts blindly hammering things together, hoping it eventually resembles a house.
That's exactly what happened.
But wait, how does a software crash translate into 30 kilos of actual physical weight on the car?
Causality there comes down to pure panic and survival. When the manufacturing process falls hopelessly behind schedule due to that software failure, you start running out of time to conduct proper structural stress tests. And worse, Williams faced unexpected failures during the mandatory FIA crash tests very late in the development cycle. When you fail a crash test with only weeks to go before the season starts, you don't have the luxury of time to engineer an elegant, lightweight solution.
You just reinforce what you have to make absolutely sure it doesn't break.
Exactly, which means adding raw mass. You slap 3 extra layers of carbon fiber onto the chassis, you beef up the bulk of the suspension arms just to guarantee it passes the safety test, and legally gets allowed on the track.
So the software collapse led to panic engineering.
Which led to a car bolted together with heavy, rushed countermeasures.
Which completely explains why they missed the Barcelona test. They were literally just trying to glue the heavy pieces together to make it to the first race.
Just to have a car to drive, yeah.
But shedding 30 kilos is essentially just an extreme mechanical diet plan. And if weight was the only issue, the car would just be a slow tractor. It would be predictably bad.
Right, but predictable.
Exactly. Here's where it gets really interesting, though. Because the FW48 is behaving like a possessed machine. If you're driving this car, it's not like driving a precision racing vehicle. It's like sprinting through a supermarket pushing a heavily loaded cart where one wobbly wheel just randomly lifts off the ground and snaps the cart in the wrong direction.
The visual of that supermarket cart is terrifyingly close to the reality on the track. In the paddock right now, this phenomenon is being referred to as three-wheeling.
Three-wheeling?
Yeah. Mid-corner, under immense aerodynamic and lateral load, the FW48 is literally lifting an inside tire a few millimeters off the track surface.
That's insane.
And the absolute nightmare for the drivers is that it isn't predictable. Depending on the corner speed and the profile of the turn, the car might three-wheel at the front, or it might suddenly three-wheel at the rear.
Okay, before we go any further, I am not a suspension engineer, and I imagine many people listening aren't either. But I know Williams is doing something bizarre with their suspension geometry. What exactly is a pull rod versus a push rod, and why on earth is this causing a modern F1 car to lift its wheels at 150 miles per hour?
Let's break down the mechanics. The suspension on an F1 car connects the wheel to the internal shock absorbers hidden inside the chassis.
Okay.
A push rod suspension has a diagonal rod that goes from low on the wheel hub up to the high part of the chassis. When the wheel hits a bump, the rod pushes up into the shock absorber.
Got it.
A pull rod is the exact opposite. It mounts high on the wheel and goes low into the chassis. When the wheel hits a bump, it pulls down on the internal mechanics.
Okay, so one pushes the force upward into the car, the other pulls it downward. That makes sense. But Williams decided to, mix and match them.
They did. They are currently the only team on the grid running a pull rod on the front of the car and a push rod on the rear.
The only team.
Yeah. Now, the rear is actually a known quantity. They purchased their gearbox and rear suspension layout directly from Mercedes. It works beautifully. But the front is a bespoke Williams design.
Ah.
They mounted the forward suspension arm incredibly high and the rear arm very low to try and clear up airflow heading to the floor of the car.
So it's essentially like a runner trying to sprint a marathon while wearing a high-tech track spike on their left foot and a heavy, stiff hiking boot on their right foot.
That's a great way to look at it.
The two ends of the body are trying to execute completely different mechanical philosophies, and the whole system just violently trips over itself.
And the tripping over itself happens because of another extreme design choice they made, the rake.
The rake angle, right.
Williams is running the most extreme rake angle on the grid, meaning the rear of the car is pitched significantly higher in the air than the front. The goal is to aggressively increase the angle of attack of the floor to suck the car into the ground and generate downforce. But to maintain that extreme high-pitched angle, you have to run an incredibly stiff suspension. If the suspension is soft, the car just squashes flat to the ground at high speeds, and your entire aerodynamic concept is ruined.
I see where this is going. The car is so stiff that it has zero mechanical compliance.
None. What's fascinating here is how quickly the physics fall apart. Because the car is so stiff, when the driver throws it into a corner and the weight transfers, the mechanical platform completely refuses to roll with the track.
Wow.
The stiffness forces that inside wheel up into the air, and the moment that tire lifts, your rubber contact patch shrinks. The mechanical grip just vanishes.
It's gone.
Completely. And the aerodynamic center of pressure, which you can think of like balancing a heavy tray of drinks on one hand, suddenly shifts violently.
And the tray tips over.
The tray tips over, the downforce collapses, and the car effectively gives up all grip in a fraction of a second.
I mean, when mechanical grip vanishes mid-corner like that, the driver loses all fundamental trust in the car. Which really brings us to the human toll of this disaster.
It's brutal.
Driving a heavy, unpredictable three-wheeling car isn't just a fascinating puzzle for an engineer back at the factory. It is an absolute psychological torture chamber for the two athletes actually strapped inside the cockpit. And we were seeing two wildly diverging reactions split the Williams garage right down the middle. On one side, you have Alex Albon, and the frustration is just palpable.
Yeah, Albon is at the peak of his physical and mental career right now, and he clearly feels like he is screaming into a void.
Completely ignored.
If you listen to his radio traffic during the races in China and Japan, he was constantly highlighting the handling deficits and specifically calling out issues with how the power unit was deploying electrical energy.
He's trying to manage so much at once.
Exactly. He has completely altered his natural driving style to try and tiptoe around this three-wheeling issue, but his frustration stems from a feeling that the engineering team just isn't acting on his feedback.
And that is the breaking point for any elite athlete. When a driver loses faith that the pit wall is actively listening to them, the relationship begins to fracture.
It really does.
But then you look across the garage at Carlos Sainz, who arrived this year amid massive fanfare, and it is a completely different universe. I mean, Sainz has adopted this deeply analytical, almost stoic approach to the crisis.
Very stoic.
He has openly admitted that the scale of this engineering failure is a shock, which is quite a loaded word from a driver. But he absolutely refuses to assign blame or point fingers.
Which raises an incredibly important question about what true leadership looks like under extreme duress in elite sports. James VOWLES actually made a fascinating internal observation recently about this.
What did he say?
He stated that the true test of a leader isn't how they act when the car is winning by 20 seconds, it's how they conduct themselves when the systems completely fail. And VOWLES praised Sainz's attitude with such genuine awe that he joked he would gladly hand Sainz his own job as team principal.
It is incredibly rare to see a driver react like this. Usually when a highly rated superstar gets strapped into a failing backmarker car, their manager is immediately on the phone scouring the paddock for an exit clause.
Looking for any way out.
Exactly. But Sainz is treating this massive factory failure as a personal engineering project. He says he doesn't know what he wants from life after his racing career ends, but right now, he is essentially acting as a co-team principal.
He really is.
He is diving into the telemetry, he's forcing the engineers to stay calm, and he's just refusing to let the garage spiral into toxicity.
It is a masterclass in mature crisis management. Sainz knows that throwing a public tantrum on the radio doesn't magically shed 30 kilos of carbon fiber. It doesn't rewrite broken ERP software.
No, it doesn't.
Only surgical, relentless engineering focus achieves that.
And thankfully for Sainz's sanity, the Formula One calendar has unexpectedly thrown Williams an absolute lifeline this year. Due to the geopolitical situation, the Gulf War tragically forcing the postponement of the Bahrain and Saudi Arabia races, the sport is currently sitting in the middle of an unprecedented 5-week gap.
5 weeks.
Yeah, between the Japanese Grand Prix and the upcoming race in Miami on May 1st. That much downtime during a racing season is an eternity. How is Williams utilizing this gap?
Well, they are treating it like a mandatory second preseason. I mean, Sainz hasn't taken a single day of vacation. He put himself into a brutal physical training camp, specifically focusing on neck strength.
because of the G-forces.
Right. If an elite driver spends 5 weeks out of a 5G cockpit, their neck muscles will literally soften, and they'll be physically destroyed by the end of the Miami race.
Wow.
He also demanded and successfully completed a full test day at Silverstone in the beloved 2025 FW47.
Just to remind his own nervous system what a competent, functioning Formula One car actually feels like.
Yes. To recalibrate his baseline, he needed to physically feel a car that doesn't lift a wheel mid-corner so he can go back to the factory, jump into the simulator, and clearly articulate the exact delta between a stable platform and the FW48.
That is so smart.
And while he is doing that simulator work, the factory is preparing a massive rescue package for Miami. James Vowles has publicly promised that Miami will show the next step in their recovery.
Okay, but what does that next step actually entail? Because bringing an upgrade package to Miami is one thing, but the FIA is also throwing a massive curveball into the mix. I know there are new 2026 regulations specifically regarding electrical energy coming into effect for this race, but I have to admit I'm a bit confused on how they actually alter the racing.
It's a complex shift in how the power units operate. Miami introduces strict new regulations regarding how the cars harvest and recover electrical energy during a qualifying lap.
Okay.
And more critically, the FIA is strictly enforcing a 250 kilowatt electrical deployment cap in specific designated race zones.
So instead of the driver just mashing the pedal and getting all the battery power whenever they want, the computer is artificially capping how much electric horsepower they can use in certain parts of the track.
Exactly. You have to perfectly program the car's software to harvest energy under braking and deploy it efficiently within those strict limits. If your software is off by even a fraction, you lose massive straight line speed. So, you are taking a Williams team that is already overwhelmed by the physical complexity of their chassis, battling a car that literally wants to lift its wheels off the ground. And now you are forcing them to adapt to brand new, highly technical power unit deployment parameters on a tight street circuit.
It's a perfect storm.
It really is. As for the upgrades themselves, Vowles is managing expectations. It won't be a finished product, but the package is aggressively focused on stripping away a significant chunk of that excess weight and adding raw aerodynamic downforce to try and glue that phantom wheel back to the tarmac.
Let's look at the big picture then, and the stakes for James Vowles. With the team sitting at the bottom of the competitive order, what does actual success look like for Williams when the lights go out in Miami?
Look, if we connect this to the broader championship picture, winning or scoring a podium is pure fantasy right now. Success for Williams is entirely about trajectory. The immediate, realistic target is catching Haas.
Haas.
Yeah, Haas is currently the leader of the midfield pack, sitting just 18 points ahead of Williams.
18 points.
In a modern F1 season, an 18-point deficit is easily erasable if you suddenly unlock a capable car. But Vowles is under immense, crushing pressure right now. The primary reason he hasn't faced serious internal calls for his job is the massive credit he banked by dragging the team to 5th place last year.
Right. He built up a lot of goodwill.
He did. But recovering this botched 2026 launch is the defining test of his tenure.
So we've seen a historic team swing for the absolute fences with these new 2026 regulations. They intentionally overloaded their own digital infrastructure, built a massively overweight car that terrifyingly lifts its wheels through high-speed corners, and pushed the psychological limits of their drivers.
Yeah, they really have.
Yet they possess a fiercely analytical leader in Carlos Sainz and an unprecedented 5-week grace period to strip the weight and fix the suspension geometry before hitting the track in Miami. So what does this all mean?
It means we might actually need to view this disaster through a completely different lens. If we embrace SAINZ'S stoic philosophy, we have to accept that linear progress is a total myth in Formula One.
You don't just naturally get better every single day.
Exactly. Sometimes you have to break the system entirely to understand its true limits. Think about the long-term implications here. If the horror of the FW48 forces the Williams factory to violently root out the hidden flaws in their simulation tools,
Right.
if it forces them to finally modernize the ERP software that collapsed under pressure, then this incredibly painful 2026 season might be the exact brutal crucible required to forge a legitimate World Championship operation for 2027 and beyond.
That's an incredible way to look at it.
And it introduces a fascinating possibility for the future of the sport, too. If SAINZ'S open source, hands-on, co-engineer approach actually saves this team from ruin, we might see a fundamental shift in how Formula One contracts are written.
Wait, really? Like requiring them to be engineers?
Yeah, future superstar drivers might not just be hired to pilot the car. They might be contractually obligated to act as part-time technical directors, permanently bridging the gap between the cockpit and the factory floor.
Sometimes you have to realize that the winning lottery ticket you thought you had was actually just the price of admission to learn how the game is really played. You won't want to miss a second of this recovery attempt. Thank you for joining us on this deep dive under the hood of the ultimate motorsport paradox. Keep your eyes absolutely glued to the Williams garage when the lights go out in Miami. It is going to be an explosive weekend.